Day 2020 Virtual Tour Edition. My name is Emmett Owens, and I represent the Research Triangle Cleantech Cluster. And I want to begin by thanking all of you for joining us. Um, as you may or may not know, each year the National Association of Manufacturers celebrates manufacturing on the first Friday in October and promotes events throughout the month. In fact, earlier this week, Governor Cooper proclaimed September 27th through October 3rd as Manufacturing Week in North Carolina. So we're excited to be celebrating National Manufacturing Day and Week with you. So thank you for your time, and we'll get to the fun stuff. Before I get too far, I want to take care of a few housekeeping items related to this webinar. During today's event, we ask that attendees remain in listen-only mode. As a heads up, we are recording this event to share with others. When you have questions for the presenters or panelists, please leverage the Zoom chat feature, and staff will direct questions to the moderator of the panel session, or in the breakout rooms, feel free to direct them to the individual. In terms of the format of the event, we're going to mix it up a little bit. We're going to have a concurrent tours in about less than 10 minutes, where you can either choose to visit with FREEDM Systems Center, which is Engineering Research Center on NC State's Centennial Campus, or you could visit with PowerSecure and get a tour of what they've got going on in their facility in Durham. And then we'll also bring everyone back together and have a manufacturing panel discussion, and then we will adjourn our meeting. And so that's kind of information, and I'll give you some more info about how you'll be able to join the virtual tours just prior to beginning that portion of the event. Now that I'm done with my housekeeping, let's jump into thanking some of the partners for today's event. So thank you to Julia from Power America and Matt from the North Carolina Sustainable Energy Association for all of their support and willingness to partner with us on this event. I also want to thank our virtual tour guides from the FREEDM Systems Center and PowerSecure. It takes a lot of work to put this kind of program together, and they have rose to the challenge and then some. And I also want to thank our panelists, Dr. Victor Veliadis, Scott Clark, and Ryan Kennedy. So we're excited to have these gentlemen speak to you about some of the manufacturing that's going on in North Carolina. For those of you who are not familiar with RTCC, we are a membership-driven nonprofit that's really focused on accelerating the growth of the clean tech in the Research Triangle in North Carolina. We wouldn't be here without our members. I urge you to check out our website. You can see it at the bottom of the slide here, researchtrianglecleantech.org, to learn more. We're in the middle of a 3-year federal grant with our partner in Jules, focused on 3 parts. You can see those there. Check out our website at Cleantech Corridor, NC Cleantech Corridor, to learn more. Again, URL is at the bottom of your screen on the slide here. And I also invite you to check out our YouTube page, see some of the content that we've done in the past. Now that I'm done with my song and dance, I'd like to ask Matt Abel and thank Matt for putting on this event with us and to provide a little bit more context about NCSEA. And Matt, I'll turn it over to you.
Great. Thanks so much, Emmett. I really appreciate the opportunity to partner with the Research Triangle Cleantech Cluster and our partners over at Power America on this event for the 2nd year in a row for NCSEA in participating in this. But I know you guys have been doing this for a number of years now. Obviously, we've had to make the transition with everything going on in COVID, but I'm really, really excited about this new virtual format we're bringing to you here today. But before we jump into the event, I just wanted to give you a little bit of background about NCSEA. So we are a 501c3 nonprofit focused on policy and advocacy work here in the clean energy space in North Carolina. We're a membership-based organization comprised of about 400 members from throughout the state, region, and country, ranging anywhere from small mom and pop HVAC installers all the way up to large technology companies, many of whom you've probably heard of. So, a few things I just wanted to bring to everybody's attention here. We're also running a concurrent webinar series coming up next week called Making Energy Work on October 6th, where we'll be featuring Jigger Shaw of the Energy Gang. So if you are interested in checking that out, we have an event taking place on October 6th at 3 o'clock in the afternoon focused on investment capital. And the last thing I'll just draw to everybody's attention is our Squeaky Clean Energy podcast, where we host a bi-weekly podcast talking about all things clean energy in North Carolina, where we've already interviewed folks like Governor Cooper, Leah Stokes, Catherine Hamilton from the Energy Gang. So if you're interested in checking out our Making Energy Work series or our podcast, you can check out our website, which is energync.org. All right. Thanks again, Emmett, for partnering with NCSEA on this event. We're really excited to be here with you.
Awesome. Thank you, Matt. And I know we'll be hearing from Dr. Valiatis in a few moments about to hear a little bit more about Power America, who is our other event partner. Now that we've kind of jumped and done our background about who we are, why we're here, we're going to jump into and transition into our virtual tours. Again, Dr. Valiatis will be leading the FREEDM Systems Center tour, and Abby Coulter will be leading the tour of PowerSecure. And each person who is participating will have the opportunity to join the tour of their choice when I launch the breakout room. If you'd like to participate in the PowerSecure Tour, you do not need to do a thing. You'll just need to stay right here in this room. However, if you would like to join the PowerSecure Tour, the FREEDM System Tour, you will need to, and bear with me while I set up the room. You will need to take a look at your screen in Zoom, and you'll see the breakout room option appear at the bottom of your screen as indicated on this slide in the blue box. Just simply click that box if you want to join the FREEDM Tour, and you'll see the FREEDM Tour appear. You click join, and you'll be taken to a separate virtual meeting room where you'll be able to enjoy some content from FREEDM and learn more about what they are, the capabilities, and all that kind of good stuff. So once you're in the room, there may be a brief pause as we wait for others to arrive. When the tour is over, I will merge the sessions back together for our panel discussion. If you're not using the desktop version of Zoom, I will most likely need to move you to the FREEDM Systems Tour. If you want to go, just send a message in the chat. I'll find you and I'll push you over towards that breakout room. Again, just send me a message if you don't wind up in the FREEDM Tour room and you'd like to be. There's some capability issues related to not having the desktop version of Zoom. So please bear with us. This is the first time doing this breakout thing. It may not be seamless, but we're making an attempt to mix it up, and we'll make sure that you're in the session you'd like to be in. So if you'd like to join the FREEDM Systems Center session, click the breakout room button and the blue box, and then right there in the bottom of your screen, and then click join now and you'll be taken. Otherwise, remain here for about 60 seconds. We'll get it kicked off for the PowerSecure Tour. Thank you all.
.12 to 10:32. So I think I should get started so we can finish on time. So good morning, everyone. My name is Victor Valiatis. My makeup artist couldn't make it in this morning, so I apologize for what you're seeing on your camera. Okay, all right, moving on with FREEDM. So FREEDM is part of the North Carolina State University ECE department. I don't directly work at FREEDM, but I'm very familiar. I'm also a professor at NC State, so I'm familiar with the capabilities, and I was asked to do an introduction. So FREEDM is a National Science Foundation, ERC, and it was established in 2008. And the goal is to create a modern power grid. So at FREEDM, which stands for Future Renewable Electric Energy Delivery and Management Systems Engineering Research Centers, there's universities that are part of it, and there's industry, and they all work together for a more secure, sustainable, environmentally friendly electric grid. So FREEDM is the typical NSF ERC with focus on the grid. And specifically in FREEDM, they're building a network of distributed energy resources that intelligently manage power using secure communications and advanced power electronics. And with that, Matt, if you would take us to the virtual tour, and I'll be here, of course, throughout the tour and at the end of the tour. And if you have any questions, I'll be happy to answer. Thank you.
Great. Thanks, Victor. And are you seeing my screen?
I am, yes.
Okay. Give me just 1 second here. Probably just pulled it off. All right. Okay. And here we go.
The FREEDM Systems Center is headquartered at NC State University near the Research Triangle Park. Initially funded by the National Science Foundation, the center coordinates with partner universities and corporate members for research in power electronics and power systems. The center's research extends from simulation and prototype development to lab testing and field deployment. Extensive power systems modeling capabilities include multiple RTDS, Opal RT, and Typhoon hardware-in-the-loop simulators. These enable test and validation of hardware and controller-in-the-loop scenarios. The center's high bay lab offers a unique configuration for testing medium voltage equipment up to 15 kilovolts with total power of 1 megawatt. The 40 kilowatt rooftop PV array, outdoor equipment test bag, and vehicle charging stations are tied into the lab power system for easy addition as loads or sources. The high bay space is highly configurable and available to industry partners for confidentially evaluating their own equipment. Many FREEDM projects focus on applications of wide bandgap semiconductors, including a center core technology, the solid-state transformer. There's a lot of work required to develop this technology, such as gallium nitride device characterization, new packaging designs and techniques, and multi-SST system performance evaluation. Other technologies developed at FREEDM include a medium voltage DC fast charger for electric cars, a novel motor winding configuration that increases induction motor efficiency, a high-density inverter that surpassed Department of Energy targets 2 years ahead of schedule, and higher efficiency wireless charging configurations. FREEDM sees a future where the traditional power system has the ability to easily connect distributed renewable energy sources, where customers may aggregate into microgrids for increased resiliency, and where DC power is more prevalent than today. This vision promises many benefits, but requires more development and collaboration with our electric utilities and equipment vendors. Contact us to learn more about our research and how you can get involved.
And I will jump into this next video here. Give me 1 second while I pull that up.
Iqbal Hussain. I'm the ABB Distinguished Professor in the Department of Electrical and Computer Engineering and also the Director of FREEDM Systems Center. So this project is about developing a traction inverter. It started with the first year of Power America Institute funding, and the project was about to demonstrate and serve as a reference of how silicon carbide devices can be used, taking advantage of their high voltage, high temperature, and high frequency operational capabilities. The BP1 project was for developing a 55 kilowatt inverter, and the BP2 was to develop a 135 kilowatt electric vehicle traction inverter. So this went through the 2 generations of development in BP1 and BP2. The first year, we worked towards developing a PCB-based busbar structure, which has never been done before. And then we acquired parts, designed and analyzed through simulation and analysis, and build it. The assembly of the different components, so the inverter has primarily like the power stage, the devices, and the heat sinks, and then on top of that it has the control cards and the gate driver cards. So we carefully planned it out using SolidWorks, of how this would be assembled in the most easiest way, and then the manufacturing challenges would get at least somewhat resolved. And the concept in itself, like PCB-based bus bars for traction inverters, allows it to be a rapid prototyping and making it easier for assembly compared to the laminated bus bar structures that is more universally used, which has more manufacturing steps and less difficult to manufacture. The concept itself lended itself towards better manufacturing. This led to other projects using silicon carbide devices. So in subsequent years, we partnered with an automotive parts supplier. They got additional funding for Department of Energy to develop a traction inverter with more power rating, with higher power ratings for an all-electric truck. So we partnered with them, providing design support and also like component testing and all of that, to lend itself towards a manufacturing for a 250 kilowatt traction inverter for an all-electric truck application. Certainly many of them has lots of potentials. For example, one of the concepts that are used in high volume manufacturing for electric vehicles is hairpin windings for those electric machines. The challenge for these electric machines is to go to higher speeds, because at higher speeds with the current winding structure, the losses become too high. The industry, like I mentioned, is looking for higher power density and also higher efficiency, so that we can go a few more miles for the same charge that we have. So with that, the challenges that are coming in now are high volume manufacturing of these components. For example, in the truck application, 250 kilowatts or higher power levels, the design is to go towards 800 volts or higher. And then with that high power rating and the higher voltages, the device current ratings would also need to be there. Yeah, I would say the number one answer would be the developments of these wide bandgap devices. So it has come a long way. Currently, at least, like we have silicon carbide devices that are available, even in sample quantities that we are able to build prototypes. And then this is also happening with other parts also, like capacitors in the higher voltages, and their performances are also getting better. So all these manufacturing of the different parts have improved significantly over the years, which is aiding the development of those systems of inverters and powertrains along with the electric machines. In general, for the development and advancement of new technologies, going all the way from technology development, prototype development, and then manufacturing, and then high volume manufacturing, right? So I believe it's the partnership that works the best between research institutions, academia, the industry partners, and then also state and federal level of support for the development of these technologies. We started with a federally funded project for the development of the inverter, and then that led to other industries working with us in collaboration. It becomes a win-win situation for all.
All right, and one last video.
I'm Wen Songyu, Associate Professor at NC State University. This project is to design, manufacturing, and testing a 30 kilowatt electric vehicle fast charger. We cooperate our design for manufacturing with high reliability, high efficiency, and low cost by using advanced silicon carbide devices. To reach 99% efficiency, we using state-of-the-art topology, circuit, device, and the thermal design with advanced computer simulation. This is the internal fin structure. Yeah, you can see that advanced silicon carbide devices made in USA from microsemi. This customized module using the high performance, low cost double-side cooling. This internal fan, not the outer fan, make the cooling efficiency 10 times better because now the pressure drop is well controlled. Infineon and the ABB company, they use similar concept. By computer simulation, you will find out the internal fin structure more thermo-efficient than the outside fin. Yeah, this is the first time we use the ceramic for low-cost design. We enjoy cooperate with microsemi from marketing team and application team. I invite 4 engineers to our lab to do the testing side by side. They give us the system guidance for marketing requirement for 3 years now. I move a digital UPS project to mass production 10 years ago. I hope this project can be successful as well. One key challenges in my area is the cost-effective manufacturing of wide bandgap devices in USA. Actually, now we are in the front end of that manufacturing process. I believe, give us, say, a few years, we will dominate this area in the world. Exactly, our partner of microsemi, they build the advanced future technology. Now we try to combine the existing market for mass production. From a system optimization point of view, we want to use the state-of-the-art technology made in USA already, but with marketing advantages over the world. Now the manufacturing of silicon carbide and the GaN devices open a big interesting area for me. For example, I use that wide bandgap devices for solid-state transformer in future grid application, also using wide bandgap for electrical vehicle applications. Without manufacturing of wide bandgap semiconductors, that research area is impossible. I hope we can really do some mass production in USA.
All right, Victor, I will pass it back on over to you.
So that was a very nice introduction of the FREEDM Center. And if there are any questions, I'd be happy to answer. The first question is this video available on your site or elsewhere? I think the video is available on the FREEDM site. Another question by Sylvia Rodriguez is whether the FREEDM Center works on high silicon carbide devices, and that's true. That's the area of expertise. And that's it. If anybody has questions, please, you can use the mic or you can type them. Okay, so just to give you a little more information, silicon carbide devices are capable of very high efficiency, and they're of small factor, and they're enabling the plus 10 kV type of applications. So a lot of the work that the FREEDM Center does is introduce silicon carbide devices and work the circuits to accommodate them, since they have high voltage, high frequency, high temperature, and high current at the same time. So that's a lot of the work towards modernizing the grid, in addition to the work that's done for resiliency and for security. So I think we're at the point where we need to move back to the main event. And I thank you very much for your attention. And of course, if there are any other questions, you can forward them to me, and I can certainly get you in touch with Iqbal Hussain, who's the director of the FREEDM Center. Thank you.
All right, everyone, if I could get someone to let me know if they can see my PowerPoint screen, that would be wonderful.
Yes.
Yeah. Yes.
Great, thank you. Okay, we'll go ahead and get started. Good morning, everyone. My name is Abby Coulter, and I'm the Customer Engagement Coordinator for PowerSecure. My role really focuses on our Microgrid 360 Tour offering, which has gone virtual for the time being, and managing both customer and educational engagement for our brand. I also have Scott Kolick with me. He is PowerSecure's General Manager and is a panelist for the session later this morning, and invite Scott to jump in along the tour presentation today. So the format of our virtual tour will be, we're going to go over just a few slides in the beginning to orient you with PowerSecure and talk a little bit about what we do. And then for the second leg of the session, we will be actually watching a 7-minute video, which dives a little bit deeper into our Durham campus, and you'll get to see some of our capabilities in real time there. So during the tour video in a bit, as I mentioned, you'll see what it means for PowerSecure to be a Microgrid 360 company. Unique in the industry, PowerSecure is 100% vertically integrated with in-house resources. And for 20 years, through our turnkey approach, it's really given us control over each aspect of a project. And this approach ensures efficiency and consistency while relying on a single point of contact. We call ourselves a one-stop shop, while also providing lifetime value to our customers, from initial concept and design through implementation and asset management. So throughout the video tour a little bit later, you'll see the microgrid development cycle highlighted from what we do, from the solutions we develop to the data we collect and monitor, to the customized solutions we create and ship out of our Durham facility. And I'd like to draw your attention to the graphic on the screen. It does a really great job of visualizing that turnkey approach. And steps really 1 through 4.5 are all completed at our facilities. And then it moves to the installation and construction and commissioning on the customer's actual site. So of course, for manufacturing day, we're going to be covering an in-depth look at step number 4, which includes, but is not limited to, fabrication, welding, power generation assembly, powder coating, low and medium voltage switchgear manufacturing and assembly, testing, both for generation and switchgear products, and also going to be highlighting what we call our intelligent manufacturing. And Scott, I'd like to kick it to you to provide some insight on what we mean by that.
Yeah, good morning, everybody. Yeah, when we talk about intelligent manufacturing, I mean, I think we have invested in some pretty smart tools and capabilities here. All of our products are generally 3D designed and different software packages, and we've found some very innovative ways to go directly from the 3D design to the machines on the floor and try to eliminate all of the steps that are between that to kind of program those machines. So, you know, for example, we're doing everything from, say, a laser machine that can cut a part. You know, that laser machine has the ability to go all the way back into our vault system and look at the design files, and I can make 10, 15, 20, 100 of those parts without anybody in the middle. And we do that for both laser machines. We do it for conduit bending. for example, that are done in 3D, bus work, and we also have automated wiring machines that create very quickly harnesses and other components that would take a lot of time to do by hand, and it does that very, very fast, does pull tests on every wire. So those types of machines that we've invested in really allow us to go from design to something that's on the floor in a very, very fast cycle time and with the quality that we're looking for.
Absolutely. Thanks, Scott. We'll get to see a few photos of those different types of machines and equipment in just a minute. But before we get there, we wanted to orient you with our DI, which stands for Distributed Infrastructure Campus, which is home to designing, developing, manufacturing, and testing our innovative microgrid solutions. And this is housed right in the center of RTP. We've got a total of 3 buildings that make up the DI campus. Building A, which you'll see back to the far left, Building B across the parking lot, which is our main manufacturing space. And then we've got a 3rd building, which is what we call Building C. You can see the trend here, which houses all of our inventory, and that's about half a mile down the street. Worth mentioning that we also have a separate manufacturing facility located in Randleman, North Carolina, and all 4 of these buildings total about 400,000 square feet of active manufacturing and office space for PowerSecure. And if you look at the layout below, which again is our largest manufacturing facility at the campus, and this rendering has changed a bit since it was made. Some things are in some different spots now, but PowerSecure's manufacturing division expands really on the vision created by our development and engineering teams. Our dedication to quality and efficiency is really unmatched as we deliver what's known as our power block generation and next gear switchgear products to our customers. Our ability to build the switchgear in-house is a major differentiator as the brains of the system to ensure it operates as desired for the customer. Our ability to also build customized generation enclosures in-house gives us the capability to directly address customer site constraints and facility needs on an efficient timeline. Another aspect of the manufacturing team is the testing and quality control division. From equipment startup through full functional testing, the team confirms each and every component as well as the entire system is ready to serve our customers and their facilities as reliably as possible before deployment. And in some cases, climate and utility outage are simulated before a generator enclosure is deployed. All really unique and a key part of our manufacturing process that we do in-house. You'll also notice as part of the rendering, individual cells in the assembly areas. Our panelist, Scott Collett, can dive into this further as our in-house expert, but I think it's worth mentioning that we run a cell-based manufacturing system to increase efficiency, lead time, and even improve safety conditions. Rather than moving large pieces of equipment down the shop floor, which can be time-consuming and hazardous, our enclosure and switchgear components are kitted into specific cells within an assembly area. So the structures are erected from the ground up within that cell. And once assembled, the structures are sent directly to their respective testing areas for quality control and functional testing before deployment. Something unique to us. Scott, not sure if you want to touch on anything there.
Yeah, I mean the cell, when we're making products in some cases that weigh 10 to 15 tons. So it's sometimes difficult to take a product like that and put it on an assembly line that physically moves. So in many cases we're bringing sub-assemblies and components into that cell and then working with lean manufacturing techniques to make sure that we minimize the amount of time that unit sits on the floor in that cell. But just the physical size of the equipment that you'll see in some of the videos will kind of bring that to light, I think. So.
Yep, absolutely. And as Scott said, you'll see more of the manufacturing floor in the video, but we wanted to give you an idea of the scale and scope of our manufacturing floor beforehand. All right, we're going to get to that video, we promise, pretty soon. But on this slide, you'll see a collage of some of the unique processes and products we design, build, test, and ship from our facility. From sheet metal fabrication with our laser cutter at the top left, to welding, assembly, and automated wiring, which Scott mentioned earlier, We are building our microgrid solutions from the ground up. And even the difference in white versus gray panels is all powder coated at our facility to ensure the greatest quality and control of our products. Something you'll get to learn more about in just a second. I'm going to keep us moving for the sake of time, and wanted to show you all the end product. So as you've heard today, we engineer and manufacture microgrid solutions, but what does that look like when it's all pulled together and deployed from our facility? And so we've actually built our own custom microgrid at our campus in Durham, which on a normal non-COVID day, you could come and visit. But today we'll be looking at it virtually, and it includes a 200 kW solar rooftop system, 50 kilowatts of fuel cells, 500 kW of battery energy storage system, custom built low voltage and medium voltage switchgear, double conversion inverters, as well as our 1250 kW power block generation system, which is all seamlessly integrated together by our microgrid controller and monitoring software. This system is able to island from the utility grid and self-operate as our microgrid system for our campus, maintaining the load of our manufacturing facilities on site. So through the processes of manufacturing, engineering, and design, this is the end product. This is our goal, to provide our customers with basic to advanced microgrid solutions. Okay, so enough talking from me today. Thank you all for listening intently before we get to the video. Scott, do you have anything else to add as I pull it up?
No, I think that's good. I think we'll go from here. Okay.
PowerSecure, providing more than 2 gigawatts of in-house engineering team analyzes your energy usage data to custom design a solution to fit your business demands.
Hi, everyone. Just want to check in. Can we hear the video, or do I need to restart?
You might want to restart. It kept going in and out.
Yeah, the audio's coming.
Apologize for that. Let me double check and make sure. Share computer sound. All right, let's try this.
We are PowerSecure, the leading distributed energy innovation company, providing more than 2 gigawatts of distributed infrastructure and over $800 million in energy efficiency solutions since 2000. And this is our campus microgrid. Welcome to our virtual tour. Guiding you through our Microgrid 360 vertically integrated approach, you'll see firsthand our experience and expertise, working together to bring your microgrid project to life. Using the most efficient and cost-effective method while also ensuring seamless delivery of your microgrid. We've got your back, from initial concept and design to implementation and asset management. We make it our business to know your business. Our in-house engineering team analyzes your energy usage data to custom design a solution to fit your business demands. As a PowerSecure customer, you can have peace of mind that your system is optimized to your needs, providing resiliency, reliability, clean energy, and economic value. This is PowerSecure, and this is what we do. We have close to 400,000 square feet of manufacturing space where our dedication to quality is unmatched. Producing from the ground up, using state-of-the-art equipment and AI technology, increases efficiency and accuracy for your microgrid. We call that intelligent manufacturing. Using best-in-class equipment, our laser cutter uses engineering specification and cuts sheet metal to the exact parameters of your system. PowerSecure builds from the ground up, running a cell-based assembly system to increase efficiency, lead time, and improve safety conditions. Using our own in-house powder coating facility helps you save on cost and lead time for final assembly. We conduct extensive quality control procedures and provide 100% testing of generation systems and switchgear cabinets on this factory floor, as well as at your site for best-in-class reliability. Our expertise in paralleling switchgear is unique and allows us to make multiple engines act like a single engine. This built-in resiliency means if one engine is out, the second engine will compensate for it. Manufacturing our own switchgear allows us to right-size your microgrid so you can realize the best economic benefit for your business. We have invested in your energy future. Our building blocks are at the ready to begin designing and building your microgrid project today. The Tier 4 final Volvo engine is an EPA-certified, ultra-clean diesel genset, bringing you 98.7% reliability, seamless paralleling, and built-in redundancy for unmatched resiliency. Our natural gas engine is also EPA certified. It is a reliable and durable power unit using any combination of natural gas, propane, or wellhead gas for quick start capacity. Our power block solution is uniquely modular, providing scalability up to a 5-engine unit enclosure and built-in redundancy to accommodate your increasing power demand. Our Skin Tight is named for its small footprint and quick installation. The Power Block M is our mobile unit featuring EPA-certified engines, allowing you to mobilize power to temporary and remote locations for disaster response that can connect to secondary tanks for virtually unlimited run times. The Power Block Cube is a stackable design with a significantly reduced footprint. This modular design simplifies site installation and site interconnection while being cost-effective and easily transported around the globe. PowerSecure provides battery energy storage solutions and has installed over 80 megawatts across the United States in support of microgrid deployments. Our Power Control Center has a highly experienced team of experts that are dedicated to monitoring your system 24/7, 365 days a year. If anything happens, we immediately notify you of the event, and then we notify the utility company. This immediate response and continuous microgrid monitoring and management service gives you the confidence to know your facility is operating properly and economically optimized. We're the largest on-demand service provider in the industry. We combine technical expertise with unparalleled resources, so you are assured your assets remain in top operational condition throughout these uncertain times and during any disaster response incident. PowerSecure not only custom designs and installs microgrids, our Durham campus is a microgrid. It consists of ultra-clean modular Tier 4 final engines that can scale up as our demand grows. Fuel cells, battery energy storage, our proprietary switchgear and paralleling controls, a solar system serving as a renewable fuel source, as well as our monitoring software. Our microgrid can island our building during outages, or if we choose to do so, for economic reasons. Our Microgrid 360 lifecycle approach, coupled with our unrivaled expertise and dedication to intelligent manufacturing, monitoring, and managing your microgrid project, has helped solidify PowerSecure as the market leader with over 1,700 microgrid installations and the highest reliability in the industry. We are invested in your energy future. We look forward to partnering with you on your microgrid project. Thank you for touring PowerSecure's 360 experience.
All right, everyone. Hopefully the sound came through better that go round for the video. But I'd like to thank you for participating in our session today. Emmett and Susan, apologize that we ran a few minutes over. I'd like to take a brief pause before we merge back together. Are there any questions before we get back as a group? All right, hearing none. Thank you all for.
I have one, if I can.
Sure.
Yeah, it's John Shea. I'm with Schneider Electric. Whose switchgear do you actually use, like circuit breakers for your units?
Hi, this is Scott. Yeah, we actually use a lot of Schneider. That's the right answer.
Just needed to see who.
But we do, Eaton Schneider. I mean, on the local, especially, and yeah, quite a bit. Now on the circuit breakers, on medium voltage gear, we'll buy the breaker and the bare structure. On MV and then LV, we're basically buying breakers. We make our own UL listed copper and structures from there, right?
Right. Okay. I see. Okay. And are these AC grids, or are these DC grids, or combination of both?
A little bit of both. I mean, depends on how the microgrid is designed. A lot of it's AC coupled, right? So we're bringing the gen sets, bringing the battery system up to AC, right, and then matching it up with the gen sets. But we have done some DC coupling as well, right? But a lot of our switchgear tends to be AC gear, right? Now,
right.
The exception, I would say, with the actual distribution gear within the battery modules, that of course is all 1,000 volt DC. Yeah.
So are these bumpless systems? Say your utility goes out, do your loads see any blips at all?
They can be designed as bumpless, right? That's what Abby referred to, the inverters that we have that allow for that bumpless transfer, but that has to be kind of designed up front. But yes, we have that capability, or we have the capability to just come in, after the outage and bring everything up to a genset and battery system, and then seamlessly bring you back to utility. But if you want a true bumpless, yes, we can do that through the double conversion inverter systems that we have. Yeah.
Based on the energy you have available through the battery.
Yeah. Correct. Yeah. Correct. Then the battery will covers it for that period of time until the gensets and the other assets are able to come in. Yeah.
Yeah. Thank you. Very impressive. Nice video. It was very good.
Yeah.
Great question. Thank you, everyone.
Yeah. Thank you all, Abby, and thank you, Scott, for providing the tour of PowerSecure, and thank you, Victor, for leading the FREEDM Systems Center tour. We certainly appreciate it. And now that we're back together, I apologize for any of the technical difficulties that we all experienced. I tested it last night at work. Apparently, I should have just assigned everybody to where they indicated they wanted to go. But nonetheless, I hope everyone benefited from those tours. Now that we're back together, I'd like to introduce the moderator of our manufacturing panel, Dr. Victor Beliadis. And Dr. Veliadis is the Executive Director and CTO of Power America, which is a U.S. Department of Energy Wide Bandgap Power Electronics Manufacturing Institute. Victor manages a large budget in excess of $30 million, and he allocates to over 35 industrial and university projects to accelerate wide bandgap manufacturing. He has 27 years of experience, he has decades of experience, has issued over 27 US patents, many book chapters. And so Victor is well qualified to lead this conversation focused on manufacturing. And so with that, Victor, I'll hand the reins over to you, and just let me know when you'd like me to advance your slides, and I'll get it done for you. Thank you, sir.
So good morning, everybody, and thank you so much for the introduction, Emmett. I also want to thank you for the time and effort you've put into, putting this together. And I fully understand, you do all the testing in the world, and of course things are going to fail, or you're going to have problems on the exact day where you're, doing the live presentations. So I'm Executive Director and CTO of Power America. And I've got a couple of slides to introduce Power America to you, and I'm honored to be moderating the panel. So if you would go to the next slide, please. Okay, so Power America is a U.S. Department of Energy Manufacturing USA Institute, and the goal of Power America is to accelerate adoption of wide bandgap power electronics. So that would be silicon carbide and GaN power devices inserted in power electronic systems. Operation was started in 2015. The budget is $140 million over a 5-year period. And Power America is managed by North Carolina State University in Raleigh, North Carolina. And what we do is we address gaps in wide bandgap power technology to enable manufacturing, high technology, manufacturing job creation, and of course the energy savings that come with these more efficient devices and power electronics. Next slide. And I just wanted to point out that the work that we're doing is in conjunction with our members, and we have 55 members that are basically driving the Institute through a member advisory committee. You probably know some of these members as far as Foundry, which is basically fabricating the device concerned. Our member is Wolfspeed, which is located in the Triangle area as well, and it's expanding very rapidly. We have other fabs across the country, like XFab and Sycamore, and we work together with material companies like Soitec. So once you fabricate the devices, they need to go into systems. So we have a number of systems companies, from Toshiba to ABB to John Deere to General Electric, as well as smaller ones. We're active in the GaN area. Companies like Infineon, GaN Systems, Transform, and NextGen are part of our network. And of course, we have companies that don't have their own foundries to make their devices and basically outsource the devices to foundries in the United States. And companies like that are Genesic, Microsemi, Microchip, and others. And last but not least, we're connected with some of the best universities in the United States in power electronics and devices. And again, the whole idea behind Power America is to take the innovations that are happening in US universities and translate them into high volume, high tech manufacturing with good paying manufacturing jobs here in the United States. And finally, we have a number of government labs like Sandia and NREL that are working together with us. And with that, thank you, and let's proceed to our panel. So our panelists today are Scott Kolick, who's the production and general manager of PowerSecure, and I'm sure he gave an excellent introduction while I was in the other room talking about FREEDM. Glad to have you here, Scott. Thank you.
Thank you, Victor.
And then we have Ryan Kennedy, which is the CEO of Atom Power. So PowerSecure is playing a very important role in energy. So it provides energy solutions in the area of distributed generation, energy storage, renewables, and energy efficiency. And those are growing rapidly by leaps and bounds. And I think, Scott, you guys have installed over 2 gigawatts of energy, and you're also helping companies drive their efficiency. With respect to atom power, I've known Ryan Kennedy for a number of years. And what Ryan Kennedy's company does is they work on circuit breakers. So if you look at the mechanical older circuit breakers that were, I guess, sufficient for the older systems, they don't have the speed and the agility that is needed for modern renewable power electronic systems. So that's where atom power comes in. They're making solid state circuit breakers using silicon carbide technology, which is efficient. And these circuit breakers are 1,000 times faster than what you would get from mechanical circuit breakers. And in addition, they don't suffer the degradation that mechanical circuit breakers suffer when you have fault events. So we'll hear more about that from both Scott and Ryan, and please proceed with your introductions.
Okay. Yeah, I can start us off. So, I thank everybody for joining, and I think through the video you saw the PowerSecure really, the 360 experience and be able to put, complex microgrids in the ground. On the manufacturing side, we feed into that complete cycle, and through the facility that you saw, we are really manufacturing product from the ground up, and we buy sheet metal, we buy circuit breakers, engines, and alternators, and we're turning that equipment into complete microgrids out the other end. So we are fabricating, we are welding, we are making switchgear, we're doing controls programming on PLCs and HMIs, assembling all of that product in-house, and then testing that product before it goes out the door. So a very vertically integrated process. So it's exciting. We have about 350 people or so that are part of the manufacturing team in all of our locations that work together to produce this very complicated equipment. So.
All right. Thanks, Victor, for the introduction. I think I've got a couple slides there. Yeah, there's the first one. So I'm Ryan Kennedy, founder and CEO of a company called Atom Power that's located here in Charlotte, North Carolina. I would say if you had to pick one thing in the power space, circuit breakers typically aren't the thing. They're one of the most established and most difficult products to get into, and certainly to fundamentally change the way we have. So my own background is about 26 years in power distribution space at various levels, from electrician to construction to engineering, now to with Atom Power. Fundamentally, we had to. I looked around the world of electrification and saw, what was coming, I think, especially with renewables and with e-mobility. And there were some functionalities that just weren't available with power systems. So, and they were mostly related to the mechanical nature of power distribution, meaning mechanical circuit breakers. So we decided to take a leap and fundamentally change that from analog to digital. And right now I have the first UL listed solid state circuit breaker in the world, meaning purely semiconductor based. I think Victor mentioned we use silicon carbide. That's correct. And maybe we could advance one more slide. I just have a quick picture to kind of show you. We're 100% vertically integrated. Now, just a caveat, that's not the PowerSecure version of that, meaning we're not bending metal. That's more of the what are we actually doing and offering to the customer. We do make a lot of stuff. It's just we're not 100% vertical in everything we make, but we offer the panel board, circuit breaker, and all the software. All those things you see, we've developed, including the silicon carbide power modules that we place into all of our solid state circuit breakers. And maybe just one more slide. Yeah, so ultimately we are kind of at the start. We've been at this since 2014. We just had our first UL listing about a year and a half ago at this point, and are progressing towards other frame sizes for circuit breakers. Right now our focus is in commercial and industrial applications as well as data centers, and are quickly with our next generation products that are coming out in December going into many more spaces. So So keep your eyes out. There's a lot of change on the way. Thank you.
Okay, and with that, we're open to questions. Let's see. Okay, well, I'll start with some questions. So the first question will be for Ryan. Let me also turn my camera on. So Ryan, obviously, as you said, circuit breakers were established in power electronics systems and utilities. What gap did you see that prompted you to advance and do work in circuit breakers? Was it part of, I know you have an extensive experience as a working licensed electrical engineer. Was it something that you saw that basically prompted you to say, hey, you know, we can do better than that and kind of exploit the new technologies to get there?
Yeah, I mean, there's a lot of things, but I would say two of the most fundamental. The first one is safety. When I started out in the industry as an electrician, one of the first things I saw was a major arc flash event. So in commercial and industrial systems that have high available fault currents, meaning lots of electricity available, typically from the utility, when things go wrong, they go wrong really bad, meaning things blow up. And I was unfortunate to witness across my career several folks be either killed or severely injured through arc flash events, particularly in the larger commercial space. So that was one, that power system just fundamentally had to get safer. When things go wrong, they shouldn't go wrong too bad. That was one. But then the other one is that the ability to make the power system flexible just isn't really there. You can do things like you can transfer from one source to another, and you can remotely control things, but unless you really get deep into it, that's very limited to certain applications. And to do otherwise with just sort of out of the box equipment is very difficult. So creating, I knew enough to know that if you can make a circuit breaker itself digital, that you could sort of change all that, because the digital circuit breaker now lets you remotely control anything through any device anywhere across any circumstances. And it could double as some things that are not circuit breakers, like transfer switches and motor controls and demand management systems. All that can be built into the circuit breaker. And I guess to answer the question, fundamentally, why the circuit breaker? And it's really because, if you look at any power system, the one common thing, across every power system, whether it's utility, commercial, industrial, residential, the one thing that's common is you got circuit breakers that are between everything, between the service coming in all the way down to the last circuit breaker feeding the receptacle or light fixture or motor or elevator. It's the one common thing, and that really should be the most flexible, dynamic, changeable, learnable device in the power system. So we decided to focus there, but fundamentally to address safety and to address that just incredible flexibility that you can achieve. You had to go solid state. You couldn't maintain a mechanical circuit breaker just because of some of the physics problems. And that's generally the two macro level things that pushed me into this space.
So thank you, thank you, Ryan. And I agree. I've done some work in that area as well, more on the theoretical level. And there's indeed a gap that you're feeling, and it's becoming more and more crucial with renewables and the green energy. So Scott, I wanted to ask you a question as well. You do a lot of work in distributed generation, energy storage, renewables, and these are all newer areas. Do you see a lot of private and government support for that type of work, number one? And number two is I would think that the business is really, really picking up. So the question is, given that those are new areas, do you have qualified people working for you? Is there a gap in the workforce training? Do you find the right people? Because all these are kind of newer type of technologies. So
yeah, great question. Thanks. Yeah, we do. I mean, there's obviously a lot of work happening at the governmental level through the labs, very involved in renewable energies and other things. So we obviously try to connect with them, right, on some of the techniques of microgrid design. But so yes, we have connections there. As far as, you know, the people that we're looking for, yeah, there are some challenges in some areas. I mean, I think, you know, what we're doing now, especially in areas in AI and other, that is a growing area for us. We've added people in that area, especially because, you know, on the AI area, you know, once we build a microgrid, then the question is, well, when does the microgrid run? When doesn't run? You know, when are you on solar? When are you on battery? When are you on gensets? That is a very complicated equation based on the economics and the desires of the site. So that's where, you know, a large area of growth for us right now is the whole area of AI and the intelligence that makes all of that happen in a way that returns, you know, from an ROI that you need. Now, from my side on the manufacturing side, we also, I mean, the products that we're doing are complicated products. So, you know, we have people obviously making the products, fabrication, welding, and assembly and electrical assembly. But ahead of all that, we have quite a few people that plan those, you know, have to plan those products through the factory, structure them in our ERP system, right? And then set up methods of manufacture that are efficient on the floor. All of that has to kind of be put together. So those are industrial engineers and manufacturing engineers and people familiar with ERP systems and shop order structures and product structures that have to kind of do all of their work really before we begin to make the product on the floor. And then on the floor, you know, we've got welders, we've got fabricators, we've got electrical assembly. You know, we've got, you know, the beauty of North Carolina is we've got, you know, a very well-educated workforce around us, right? So we haven't had, you know, huge problems finding the right people. But I would say, and it may sound surprising that if you look at the unemployment where we are today, it's still tough finding welders and electrical assembly and tradespeople that really are skilled. That is still a challenge for us. And, you know, that's where I think we're looking, you know, to partner with some of the community colleges and other places around to really find ways that, you know, people can go to school for those trades and then potentially have some work opportunities here at the same time. So that's a challenge, right? Even more of a challenge, I'll say, than some of the engineering talent.
So that exactly brings us to the next question, and thank you for your answer, Scott. So this is for both of you. Given that, you know, you're working in kind of highly specialized technical areas, what type of manufacturing jobs do you hire for? What type of people are you looking for? And I guess if people want to train for the new, I guess, renewable economy, what type of skills do you think will be valuable in the industry?
Great question. Ryan, I'll let you take a first stab and then I'll pile on.
Yeah. So we're kind of specific on that, I guess, in the sense that it's not necessarily mechanical skills; it's more electronic skills, since our breakers are purely electronic at this point. So though some mechanics is involved, but I would say more electronics testing with power systems. I think Victor, you mentioned, like, you know, what kind of opportunities maybe would we have out there, or what should we be looking at? I think that, you know, the one gap we tend to have, I think, in North Carolina and probably the rest of the U.S. is, if you think about it, anything related to you know, energy and you know, producing energy or transferring energy or pulling energy from somewhere else, right? Green energy, whatever you want to call it. It all involves power conversion. And power conversion is a big industry and is a key component. The components of power conversion, meaning the semiconductors themselves, are a key component in just about every single, you know, renewable space out there today. So the one thing we probably should focus on a little bit more, I think, is having the ability and I say the skill set to make the actual power modules, right, out of silicon carbide and other, really to accommodate that industry. We do good in manufacturing the the wafers and dies that are in the modules, but the actual power modules that you would put into a piece of equipment to do the power conversion, that's something we have a little bit of a gap on, I think, that we could probably improve on. But I think that improve on means there's lots of opportunity there, and I think we're probably going to see that. But that really spreads across every industry. I'm sure it does PowerSecure. It definitely does us. Is actually having power conversion modules being built in U.S. and ideally North Carolina.
Yeah, I'm going to pile on that one too, Ryan. I think especially when we get into battery systems and energy storage systems, there's still a lot of the componentry that we use and have to source around those components still are coming from Europe or Asia, right? And that's a challenge right now, right? Especially on the DC side. So, we have great on the AC side and circuit breakers and everything else that we make pretty good, very local supplies for that. But yeah, it's those are long supply chains, but they're critical components to creating the renewable energy side of what we do. So that would be nice to see that, some more options locally for that for sure.
That is a lot of what Power America is working on, a lot of the modules and getting these wide bandgap technologies basically out there that have renewable applications. So hopefully we are training the next generation of students. So if you're interested, just let me know. There might be some people that, some students that you might be interested in for internships and potentially to hire. So another area that I wanted to go into is a question that I have here, and that has to do with cybersecurity on the manufacturing floor, the customer installation. So obviously, a lot of the operations become highly automated. So the question is cybersecurity, people hacking into your operations, is that a concern of yours, and how do you deal with that?
I mean, it's certainly a concern globally, right, for power systems. I think there's a big piece of the designs that we do within the microgrid that, protect that microgrid against outside interferences. There's a lot of componentry that we do that could connect to the internet that don't, right, that we leave several islanders as well, so that there's no opportunity for them to be, interfaced from the outside world. But it's a big part of the design of the microgrid now, that cybersecurity for sure, right? And that's gonna, it's gonna vary site to site and client to client a little bit, but we take some pretty good efforts to make sure that the microgrid is secure.
Yeah, for us, cybersecurity is it's almost priority one, both in our own products, but also to ensure that we're safe. I mean, we take certain measures, internally. The good news is for us on the method of manufacturing that we've taken on, there's not a lot of risk there, but there is risk. And yeah, we take certain measures like closed networks and things like that. But other than that, we're always keeping our eye out for how to better address that. There's no there doesn't seem to be an out-of-the-box solution to be secure. So it just kind of evolves. We evolve with it, I guess, to know what we need to do next.
Okay, so one question, I guess that's probably more for Scott. So the question is, do you see companies and municipalities moving off the grid? So kind of based on their own microgrid structure, and how far away would we be from that?
I mean, we'll see that occasionally. Somebody who really wants to go, say, completely off grid. It's probably still rare, right? I think, for the most part, people are looking for, resiliency. They want the power to stay on throughout power outages and hurricanes and all the things that, we see today. They want the power to stay on. So they're looking for, microgrid system solutions that do that, but, looking for them to participate really with the grid in a way that returns, lowers their cost. If the system just sits on its own, okay, that's fine. You purchase a system and the power goes out, it comes on, but there's a lot more benefit from an ROI perspective for it to participate in the grid. So when the grid is stressed and electric prices are high, you use the available generation to participate in the grid and lower the cost of that system. So you get the reliability and you get a better ROI. And then we call the third R in that, which is really reduced carbon footprint. We think we can put a microgrid together that does all three of those: reduces your footprint, produces an ROI, and gives you the resiliency you want. Resiliency used to be more focused on things like data centers, but good example now is when you look at grocery stores, for example, you walk in there and look at the amount of product that they have, frozen foods and other things, and you think about when that store goes out without power for 2, 3, 4 hours even, they're potentially they will throw away all of that product, okay? And the economic cost of that and the impact on the community that relies on, you getting the food out of that store. I mean, that is a critical application. And those are places that we are now, designing microgrids to protect those facilities, but also working with them in a way that gives an ROI. So we see that a little bit more, Victor, than people saying, I'm done with the grid, let's go off grid, yeah?
Right. So the off the grid would be, in a way, kind of a backup, right? But you still see people wanting to be connected to the grid, right?
Yeah, I think that in most cases, yeah, the grid connection is there, and we are really an extension of that grid connection to just provide, and the grid is very reliable, to be honest, right? So, but we're providing that extra layer of reliability on top of what in most cases of the U.S. is already a very reliable grid.
Okay, so the next question I have is, I know, Ryan, you started a small company, and obviously, even with the greatest of ideas, survival depends on getting, your finances in place. So how difficult has it been getting funded in order to, kind of realize your ideas and your technology? And what would you say is the biggest obstacle to receiving funding, and what is it that people should do to make their technology known and attract investors? And of course, that question is also for you, Scott, although I understand your company is a little more established and bigger. You're certainly not a startup. So Ryan?
Yeah, I think that location, has definitely plays a part in venture capital type of funding in general. You don't see as much where we're at as you do on the West Coast, for example. That will probably change, as we evolve forward. But yeah, for us, there's a couple, ideas on that. I mean, one is that we, I think culturally tend to be fairly humble in this neck of the woods, in that we don't really push as hard as we could sometimes on what we're doing and just how cool it is and that sort of thing. You do see that in different areas of the United States. So that definitely helps. But I would say, tactically speaking, building prototypes is the most effective way. And that was one of the things that we took on before we ever decided, for a long time, we weren't funded at all, aside from self-funding. But we knew we had to build an operational prototype, an actual workable prototype of a solid-state circuit breaker that had impact. And I would say, specific to the so yeah, that's one thing is build a prototype. Theoretical slideware doesn't tend to work, at least on the East Coast. It does tend to work on the West Coast more, but not on this side, I would say. But the other thing is, I mean, specific to the power industries, anything related to power, it's a more difficult path to get funding if you're doing anything with power, because, and I don't quite know why. I think it's because of potentially the adoption rate and how hard it is to get new products into power industries. But we kind of have this metric we've assumed over time that says realistically, like to have a product that would get, or a company that would get funded in the energy space, you got to be doing something about 10 times better. And in other industries, you can get by with 10% better or 5% or 25%. it seems that in the power space, there is a 10x requirement. Some pain point, and you're doing it 10 times better. That seems to move the needle when it comes to investment interest. You know, like, and I think it has to do with just how difficult it is to adopt new things in the power industries, whether it's batteries or circuit breakers or conversion equipment. It's difficult. It's generally hardware that you have to go then test and qualify and make sure that you burn it in for some period of time. And there's an uphill battle. It's an achievable battle, but it's uphill. And I think that's one thing that potentially other companies that look for funding in the power and energy space miss, is it has to be a big impact for investors to really see that that it's a viable entity to invest in. And I think we've done that, thankfully, and we've been able to achieve that funding, but it was much more difficult early on in our career to do that. But to get that even first nugget, we had to build an actual workable prototype of the product. I'm done with my answer.
I think we lost Victor a sec here.
No, I think he's on mute.
Oh, okay.
Okay, yeah. So I was saying that, you know, two things. The first thing is that, you know, people will not put money in a PowerPoint presentation. You've got to have the prototype to get people excited and draw people in, which makes total sense. The second thing you said is something that I've also experienced, that the power electronics industry is very, very conservative, and it's very hard to come in with new technologies. They're used to doing things in a certain way. They're risk averse. So it takes a lot of effort to make the change and make those introductions. So Scott, from your end, I guess building your business, finding investments, expanding, and particularly given that you're, you know, working with renewable technologies that are very, very different than the, you know, the coal-powered traditional, you know, infrastructure. How do you find yourself building the business and convincing the people and you know, talking about renewables as a viable source or supplementary source to the fossil fuels and coal and everything else?
Yeah. Okay. Yeah. Good question. You know, we spend, you know, we have quite a investments in R&D, and we've got the scale to do most, you know, the majority of that we fund ourselves through R&D efforts, and those R&D efforts right now are focused a lot on the renewable energy components of the microgrids, you know, battery storage, energy storage, solar, microgrid controls, and the AI that kind of is the brain to make that all work. So there's significant investments we're making in those areas right now to kind of stay on the cutting edge of microgrids. So as far as talking to customers in terms of, you know, what works for them, you know, each customer is a little bit different. Each one has a little different idea of where they want to be on the renewable energy side, you know, on the carbon side. And then each facility has differences in the resiliency requirements and everything else. So really, you know, as Abby explained, right up front, we have groups on the application engineering side that sit with the customers and say, you know, what are you trying to achieve? You know, what are your resiliency goals? What are your renewable energy goals, right? And then we try to meet those, but we also come back to the ROI. How do we make this system affordable? How do we make this so you don't have to spend 3 times as much to be green, right? We can do all. We can make it an affordable system, and we can be green, right? So, but that requires, you know, grid participation, starting and stopping at the right times, you know, working with the markets. But we've got, that if you take that approach that we can do all of that on a customer by customer basis, that's how we are, you know, growing, and that's how we're finding sites that are adopting more and more microgrids, right? But it's a unique process with each customer and each site, really, to be honest.
Okay, yeah. There are a lot of challenges, and especially when you come with new technology, you know, you want to stay on the safe side and what they were doing before. So another question would be, And I think Ryan kind of touched upon that, when he said that, if you're on the West Coast, you're more likely to find, investors might be a little easier. So the question is, how easy is it to do business in North Carolina? Is the government, the state supportive of these new technologies, of these efforts? Are they behind you, kind of helping with some cost share? What's your experience doing business in North Carolina?
Ryan, if you want to start first, and
Yeah, I mean, I'm definitely partial to that question. I'm a Charlotte native and probably more partial to the Charlotte version of that answer, but I think it does spread across North Carolina. There is a very friendly business environment here in the state, certainly in the region, but definitely in the state. That is, I didn't discover how different that was until I kind of got out a little bit more, in that people and companies tend to want to help you out, and again, the reasons behind that, not sure, but it's good. But it tends to be the culture and the environment that we have here. So we have found a lot of support, both within our, from individuals to other companies that want to help us. We do work with a lot of the companies that are probably, here in this meeting, from at various levels, as well as, with the universities, and some of the, I would say, government, especially the DOE kind of arrangements with some of those entities has been very, very beneficial. I mean, Power America is one of them, to where there's a good collective mind around power, it seems to be. I mean, this is one of the things that kind of isn't marketed well enough in some degree, is that North Carolina, particularly between Charlotte and Raleigh, are power, power centers. They really are. Between what's happening at the UNC Charlotte, the EPIC Center, to NC State, especially in the power conversion, power electronics, that's a great combination. And I think our company's colliding those two. Power electronics mixed with power distribution, which is great for us. But I think for us, maybe it's specific to what we're doing, but I think it's been a terrific environment and very helpful. We've always gotten help, and I think we found that pretty much unilaterally in our community, everyone's willing to help, and we're willing to help too. But yeah, especially as we were starting up, we got tremendous support.
Yeah, and I echo that. I mean, we have a very friendly environment here for us, in Carolina. So, we enjoy that, and I think we try to be a good corporate citizen in return, right? Our goal is to, provide great jobs for people and opportunities for people to come and learn and grow. We partner with the universities. We host a large group of interns every year, right? And that's a great experience for them. And we benefit from that and connecting to the university system. So I think, just the overall environment here is very, very positive. And like Ryan said, the high tech nature, there's a lot of power distribution and power generation companies around us, with Schneider and Eaton and ABB and all these kind of companies. So there's just a lot of expertise in power and power generation in this area that we benefit from greatly. So,
Okay, well, thank you so much for your answers. And I think we're right at the a little past the 11:15 a.m. mark. So I appreciate your time. I know you're both extremely busy, and thank you so much for sharing. And let's hope and do our best to boost manufacturing in the United States. It's not only to create high-tech manufacturing jobs and keep the unemployment low, create new products, but a strong manufacturing base is also very important for the national security of the United States. And that should never be underestimated. You don't want to depend for your crucial manufacturing, from overseas, right? You want to do it here and you want to do it well. So I'm glad to see you guys, and I wish you the best of luck in your companies moving forward. Thank you so much. And Amit, you have this. So Emmett, we cannot hear you.
Sorry, I did that's a problem with having two mute buttons and trying to manage them. I apologize. So basically, let me rewind it. Thank you all for joining us. Thank you, Victor, for moderating this panel and for being a partner on it. Thank you to NCSEA for also partnering. Thank you to PowerSecure for pulling double duty here, for hosting, being a part of this panel and hosting a virtual tour. And thank you to Ryan Kennedy from Atom Power. We appreciate it, and great to see the success that you've had in North Carolina. It's really a wonderful, wonderful story for our energy ecosystem. So with that, let the session be done. And thank you all. And I hope you all have a pleasant weekend. Enjoy the nice fall weather. Thank you all.
Thanks, everyone.
Bye-bye, everybody. Thank you.